Let's take question number 2. Here we have a simply supported beam loaded as shown in figure. The diagram is given. Draw SFD and BMD, full stop. Locate point of contraflexure if any. This is the question which we have in front of us. Now as they have given, we can see overhanging beam here. I will draw, or you can say write the data first, and the data is in the form of a diagram. So let us start with question number 2. In the data part, I will draw the beam once again. So this is the diagram of the beam which we have. Here the question is, we have to draw SFD and BMD and even locate the point of contraflexure if there is any. So these are the questions which we have. Let us try to get the solution. Step number 1, as usual, it would be calculation of support reactions. In this, I will say that since I have supports at B and C, so I will be calculating reaction at B and reaction at C. The first condition is, I will say summation of Fy is equal to 0, that is upward forces positive and downward forces negative. So here I have RB plus RC minus 200 minus 180 into the total distances, since this UDL is acting over entire span, it is 10 meters, so 180 into 10 is equal to 0. Therefore, I will be getting RB plus RC value is equal to 2000 Newton. I will keep this as my first equation. Next, I'll say that taking moments at point B, summation of moments about point B is equal to 0. Clockwise moments are positive and anti-clockwise moments negative. So therefore, if I am taking moment at B, I have RC which is upward, and if I take the moment, it is in anti-clockwise direction and distance is 7 meters, so it is minus RC into 7. Next, here I have 180 and it is the total value, it is 180 into 10, that's 1800 Newton. It will be acting at exactly center of this beam, that is at 5 meters. So if I take exactly 5 meters, this will be 1 plus 3.5, that is the half of 7, 3.5, and just ahead of it, that is 4. So here the distance would be, it would be exactly at half, that is at 5 meters. So here I have 1 plus 4, that would be 4 meters. So plus 180, that is 1800 into 4 meters. Then here I have 200 Newton acting downward and it will be producing anti-clockwise moment. So minus 200 into 1 is equal to 0. If I calculate these terms, I will be getting RC value as, it comes out to be 1000 Newton. Next, after this I will say put RC is equal to 1000 Newton in equation 1. So therefore I have RB plus 1000 is equal to 2000. So therefore RB value will also be of 1000 Newton. So here I have got the reactions. Now after completing this, that is step number 1, I will go on to step number 2, that is shear force calculations. SF calculations. For this, I will first draw the sign convention. Now, when I am calculating shear force, first I will calculate it at point A. For that, I will be taking the section just close to A on the right side. If I take this section, to the left of it, I have 200 Newton which is acting downward. So, to the left of section, if there is downward load, it is negative. So, here I have minus 200 Newton. Next, SF at point B. Here I will be getting two values. So, first I will take the section to the left. So, if my section is to the left, I have 200 Newton downward. So, here SF at point B is minus 200. 180 Newton per meter, if it acts on 1 meter distance, that will be 180 into 180 Newton acting downward. So, again negative. This is minus 380 Newton. Next, again I will calculate SF at point B. Here, now I will take the section on the right side. Right of B. 200 is downward. So, minus 200. 180 into 1, that is also downward, so negative. 1000 is upward, so positive. So, here if I calculate this, I will be getting my answer as 620 Newton positive. So, I have calculated shear force at point B. Now, after this, I will calculate shear force at point C. And again, at point C, I would be getting two values of shear force. First, I'll take the section to the left. And to the left of this, I have some forces. 200 is downward, so negative. Then here I have 180 into 1, that would be minus 180. Next, I have RB as upward, so positive, plus 1000. Then I have 180 into 7, that comes out to be, it is negative 1260 is equal to the value which I get here, it comes out to be negative minus 640 Newton. Again I will calculate SF at point C, that is, here I will take the section to the right of C. So, here if I take this section, if I look at the forces, here I have minus 200, minus 180, plus 1000, minus 1260. So, this is the value which I am getting, and plus 1000 in that. So, it comes out to be plus 360 Newton. So, two values I am getting of shear force. Now, after this, I will say that SF, here I have calculated over RC. Next, at point D, I will be getting the answer of shear force as 0. SF at point D is equal to 0.